Hey students, in this video I'm going to go over examples of how to write equations of parallel and perpendicular lines. I will go over every problem, so if you want to fast forward the video to where you need to look at, or pause the video so you can work on the problem and then check if you did it right, that's fine. So just, sorry that it's a lengthy video, but I'm going to try to go over all of the questions. Okay, so just a reminder, parallel lines means they have the same slope. So you have to recognize that if you want to write an equation of a line with this same slope, what's the slope right now? This is following y equals mx plus b. So the slope right here is next to x. So the number 1 is the slope right now. Parallel to that, the parallel slope will be a 1. We are going to use this point and use it as x1, y1 in the point slope formula. So we're going to have y minus y1 equals mx minus x1. So this formula is used whenever we have a point to replace right here y1 and x1. And then we have a slope given. In this case, we have the slope of 1. And we have the x value of 2 and the y value of 2. So we're going to have y minus 2 equals 1, x minus 2. So we just replaced these values with the given information. Now we simplify because our goal is to make it look in slope inertia form, which is y equals mx plus b. So we're going to distribute and have y minus 2 equals 1x minus 2. And then we're going to get rid of this minus 2 right here by adding 2. Therefore, it cancels here, but it's also going to cancel right here, and you're going to end up with y equals 1x. Or we're just going to have y equals x. Just to verify the work that you are doing, you can go ahead and graph this on a calculator, and you can just verify that the equation they give you right here is parallel to the equation you found, and also the point you found goes through that equation you created. So just a sketch of this will be y equals x plus 4, touching at 4, and creating a line that looks like this. So this is the given line. And then you're going to imagine that point being plotted, so somewhere here. And this is the equation you created. And notice how it does go through the point that they're giving you, and it's parallel to the given line. All right, so the next problem is similar. We're going to have a parallel line. However, this x equals 0 is a special line. This is a line where you either have a horizontal or a vertical line. The acronym that I've shown in class is HOIBUX. This acronym reminds you of which line is x equals. If it's y equals, it's horizontal. If it's x equals, it's vertical. So in this case, we're looking at a vertical line with an undefined slope, and the equation is x equals a number. To give you a visual what this means, it means that we have a lot of points, and all of these points have x equals 0. So let's say I come up with random numbers, and if we plot those, it will be these points right here. That means it creates a vertical line on the y-axis when x equals 0. And if you have to write a parallel line to that, you need another line that is like that, just parallel somewhere else. And it has to go through the point 4, 3. So 1, 2, 3, 4, and then 3 is like right here. So we're going to create a parallel line to that, and it's crossing at 4. So x equals 4 is your equation for that. Now, I saw some of you in class doing the y minus y1 equals mx minus x1 formula. However, the slope right here is undefined. So if you replace an undefined slope right here, we can't really define anything here. And then y minus y1 is going to result with just y minus 3 equals nothing, so 0. And then that's going to be y equals 3 when you move this by adding 3. Now y equals 3, it's saying that you're going to have points where y is always 3. So like 1, 3, 2, 3, 3, 3. And that means that if you graph that, it will be a horizontal line. like that. So this is an example of a perpendicular line to a vertical line, but we want a parallel line. Sorry, I just saw the paper move. I'm sorry. Here's the answer, x equals 4. X equals 4, y equals x. All right, for the next one, we have parallel again. I think I'm just going to make a video for parallel separate than the perpendicular. So parallel will be same slope for this, which is 3. And we're going to use these as x1, y1. So y minus y1 equals mx minus x1. We replace this, and this. So we're going to have y minus negative 4 equals the slope of 3, x minus 2. So when we have a negative 4 substituted here, we're going to have minus negative, which this becomes y plus 4 because of double negative. And then this is distributed in, so 3x minus 6. From there, we get minus 4 on both sides to cancel that, and y equals 3x minus 10. So that will be the parallel line. And just the visual again will be this touching at 2, having a slope of 3. So that's the given one. And then the point is 2, negative 4, so somewhere here. And then this means that you're going to have negative 10 as your y-intercept. So imagine going down all the way till you have negative 10. And then the line goes right there. So this is the one you created. And it is parallel and it's touching at 2, negative 4. All right, one more example here. We have parallel line again. So we're going to do the same slope, negative 2/5. And on this one, the equation of y minus y1 equals mx minus x1 is going to look like this. Y minus negative 1 equals negative 2/5 x minus 2. Then we rewrite this as y plus 1. And then this becomes negative 2/5 x plus, right here, if you want to multiply by hand, you do 2/5, negative 2/5 times negative 2. That's over 1. And when you multiply straight across, you get 4 and 5. So this is going to give you 4/5. We can either cancel the fraction by multiplying times 5, but I also want to show you what happens if you don't. It's just fractions, like you can't get away from them. You can either subtract 1 from both sides, and you end up with y equals negative 2/5 x. And then when you do 4/5 minus 1, this goes back to the rules of common denominator. If right now is 1 over 1, we're going to multiply it times 5, just so this can be also fifths. So you're going to have 4/5 minus 5/5, and then that results in 4 minus 5, which is negative 1, and then that's negative 1/5. So right here, we're going to have negative 1/5. And just so you can see that we would have gotten the same answer if we would have multiplied, let me show you that example. Okay. So to get rid of the fraction, we could multiply already by 5. And then we will be multiplying only these 3 parts because this is inside the parentheses. So instead of multiplying it in, we're getting rid of the fraction. So we're going to have 5y plus 5 equals, and then 5 times negative 2/5. The whole point of that is to get rid of the fraction. So this will give you like negative 10 over 5, which results in negative 2. And again, that's the shortcut of getting rid of a fraction so you can keep the numerator as the answer. So notice we got negative 2 as the answer. Next, we're going to distribute the negative 2, and we're going to get negative 2x plus 4. On this side, we're going to subtract 5. And now we have 5y equals negative 2x minus 1. And then we divide by 5. So y equals negative 2/5 x minus 1/5. So notice that we got the same answer, but just a different route. And of course, there's another different route where you could have had the distribution of negative 2/5 and then getting rid of the fraction. So like if you distributed first, you would have had this as an answer. And then to get rid of the fraction, we could then multiply times 5. But this one you do want to multiply every part. So you will have 5y plus 5 equals, and then the division of 5 cancels with the multiplication of 5, so you have negative 2x plus 4 divided by 5, and again the division of 5 cancels by 5, multiplying times 5, so plus 4. And then this results in this part right here. So then therefore all the steps follow and you end up with that answer. All right, I'll have another video for the perpendicular part of this.